Hello students, good afternoon. JNB Daman students, you are waiting for a long time. Then JNV P. P means Palakkad or Prakasham or what is that? JNV P. JNV Palakkad, I think. Last class Palakkad was there. Right. So we will start it. So it's almost, yeah, it's 3 o'clock. Right. So first of all, I'm launching the technical check for you. Okay. So if my audible and if my screen is properly visible, give some positive sign. Otherwise, let me know. We will solve it and we will start it. Okay. Fine. So it is perfectly okay. Okay. Jen Vidaman and Jen VP. So I'm ending the poll here. Yeah, 2 out of 2. Great. So I'm ending the poll. So we are studying about our organic chemistry. So IUPAC, you know everything about IUPAC. Then we are studying about GOC and isomerism, that is done. So in the last class, we have studied about what? So in the last class, we have studied about, okay, resonance and how to explain the stability of resonating structures. So today, we will study about some more important points. Actually, this electrophiles and nucleophiles. That is the first topic. Today's first topic, that is electrophiles and nucleophiles. So next year, okay, next year it is going to be very important for you, this electrophiles and nucleophiles. So now itself, you have to clear the concept of electrophiles and nucleophiles. It is very simple. Next year, you will say some electrophile is coming. Then what reaction will take place? Next year, you have to do that. So let us check it. What is this electrophile? So can anyone tell me what is this electrophile? Electro from the word itself, that is electron, right? Then second, we have phile, that is loving. So electron loving. So someone is going there, right? So he or she wants to find the love. So electron loving. Okay. Or I can say these electrophiles are electron deficient. So they need these electrons. Or I can say electron deficient. That means they are very poor. Or so very poor. They are very poor people, very poor people. So they need some money. Money means electrons. So they are going to find the electron or money. So they are electron deficient, or I can say electron loving. That is why they need some money because they are poor. Then other features, they need vacant orbitals. So vacant orbital means, suppose I'm a rich guy, I'm ready to give electron or money to these people. But so I am staying in some foreign country, South Africa. So I had to send the money. So in order to do that, there should be a bank account. So there should be a vacant bank account. Then only I can send the money. So I can say electrophiles are electron loving or electron deficient, very poor. Then they should require vacant orbital. Then only I can send the money. So that is it, electrophile. So there are different types of electrophiles. So let us study about that. First one, charged. So generally, we will represent electrophile like this, E plus. E plus, that means positive charge. Charged, which are the examples? So R plus, Br plus, NO2 plus, NO plus. They are all charged species. They are also electrophiles. For example, what is this R plus? So that is, I'm taking CH3 plus, our carbocation, methyl carbocation. So I'm drawing it carbon, hydrogen, then hydrogen, there is plus charge. So can you tell me how many electrons are present for this carbon after forming the bond? Okay, I will tell you. So how many electrons are there for carbon? So let us check that. So in this first bond, there are 2 electrons. Here also 2 electrons. Here also 2 electrons. Positive charge means that is a vacant orbital. That is, there is no electron present in that orbital. Positive, vacant orbital. Negative, it is fully filled orbital. So we have studied about that in resonance. So this carbon, it has only 6 electrons, even after forming the bond. So octet is not complete. So they are electron deficient. So we can say electrophiles. So you can check the charge species R plus, Br plus, NO plus, NO2 plus. These are the examples for electrophiles. Then another class. So what is that? So electrophiles can be electron deficient. We will represent electrophile by writing E plus. So it is not required always this electrophile should be with positive charge. Okay, some neutral species are present. So they are electron deficient. Electron deficient means they need electron, they need money. So which are the electron deficient species? That we can call it as electrophiles. For example, BH3, again chemical bonding chapter. So boron, we have hydrogen, hydrogen, hydrogen. So can you tell me how many electrons are present in boron after the bond formation? You two friends, you can give me the answer in the live chat section. So we can check that. So we have 1, 2, 3, 4, 5, 6, only 6 electron. Is octet complete? No. So octet is not complete. So I can call them as electron deficient species. So they need money. So for example, AlCl3, BCl3, you can check that they are electron deficient species. And these two, RCHO, what is that? Aldehyde. Then we have ketone. Actually, they are amphiphile. What is this amphiphile? So amphiphile means amphiphile. So amphiphile means they can act as electrophile as well as nucleophile. So nucleophile, that is Nu minus. So amphiphile. So it can act as an electrophile as well as a nucleophile. So our aldehyde group carbonyl complex, aldehyde and ketone, right? So these are the examples for electrophiles. One more, vacant bank account, that is vacant orbital. So I had to send the money to that people. So you can check this again, chemical bonding chapter. So FeCl3, iron 26, ground state, excited state. So 3 bonds are formed with chlorine. Still there will be a vacant orbital. So you have to check that. You have to do it as a homework. FeCl3, PCl3, PCl5. These are the examples for vacant orbital. So vacant orbital is present. So they can take money from other people. Then if positive charge is present, is that species always an electrophile? No. They should be electron deficient or they can be vacant orbital. So for example, we have Na plus and Ca2 plus. They are positively charged, right? We will represent electrophile by E plus, but Na plus and Ca2 plus, they are not electrophiles. So what is the reason for that? They have complete octet. Complete octet. They don't need money. So they are almost moderate people, okay? So no need of money. They are not electron deficient. So they are not electrophiles. So that is an example. So this is our electrophiles E plus. Then second, okay. So electrophilicity. Electrophilicity means the power of this electrophile. If it is electron deficient, that means very poor. It has a tendency to gain electron. It has a tendency to get money from other people. So electron deficiency means electrophilicity is high. It has a tendency to get money. Okay. So electrophilicity power is high. That means it is highly reactive in nature. So if reactivity is high, what about stability? Reactivity and stability, they are inversely proportional to each other. So I can write the next point. So electrophilicity proportional to electron deficiency. That is proportional to reactivity, proportional 1 by stability, or inversely proportional to stability. Okay, electrophilicity means that is a power of our electrophile. Electron deficient, more power. That is about electrophiles. Only you have to understand small points. Then CO2. Example CO2, you know how to write the structure of CO2. CO2 has complete octet and does not have any vacant orbital. Still, it is acting as an electrophile. What is the reason for that? So to explain the reason for that, we have to draw the structure of that one. So what is the structure of carbon dioxide? That is linear. So what is a hybridization? Sp. What is a bond angle? That is 180 degree. You know everything about that. So what is happening here? A nucleophile is coming. For the time being, so think like that, nucleophile with a negative charge. So in the next slide, I will explain what is this nucleophile. So Nu minus, it is coming. So it is coming towards our carbon. Okay. So Nu minus, that is our guest. So our guest or a new friend. One new friend is coming towards our carbon. Okay. So there is bond between carbon and oxygen. So this is our guest, right? So carbon is thinking that I should accept the guest. I should accept the new friend. So in order to do that, so carbon is breaking the bond of friendship with this oxygen. So that means this bond is getting broken. Electrons are getting shifted to this oxygen. So it will get negative this will get positive charge, right? Positive charge, that is electrophilic center. Okay, then Nu minus with negative charge, it will come and attack our positively charged carbon, that is electrophilic center. So I can say carbon dioxide can act as an electrophile. Why? In the presence of Nu minus, it is breaking the bond. So friendship, the strength of the friendship that is decreased due to a new guest or new friend. So that is happening here. So C plus charge like an electrophile. So we can call carbon, this one as an electrophilic, this carbon as an electrophilic center. Electrophilic center. So this happens in the presence of a new friend, that is our nucleophile, Nu minus with a negative charge. Okay, Nu minus nucleophile. Electrophile means electron loving. Nucleophile means nucleus loving. That means they have positive charge. So they need positive charge. So they are coming towards this positively charged carbon. Okay, so that is why CO2 is acting as an electrophile. So next one, what is nucleophile? So of course, you know the answer. They are nucleus loving, or I can say they are electron rich. So they are very rich people. So they are very rich. So rich means they have a lot of money, but they don't have a positive mindset. They don't have peace. So they want a partner. They are searching for a partner with a positive mindset or some peace. Okay. So rich guy is searching for the partner. So it is rich. It has a lot of money. So it is ready to give the money for the partner. So I can say lone pair or pi electron cloud. Electron rich, right? So lone pair electrons, pi electron cloud. It is, that means electrons are present. So our nucleophile means nucleus loving or electron rich. So it is trying to find a partner with positive charge, right? So last case, carbon, electrophilic center. So they should have lone pair or pi electron cloud. Similar to the last case, we can see different kinds of nucleophiles, which are the first one, charge. So nucleophile, so general representation, that is Nu minus, so negative charge. So charged species. So we have Cl minus. So you can write the Lewis dot structures. So Cl minus, it is electron rich. So it is ready to Cl minus, negative charge, electrons are present. It is ready to give the electrons. Okay. OH minus, NH2 minus, HSO4 minus. These are examples for charged nucleophile. So doubt. So if there is no charge, if there is no negative charge, is there species without negative charge acting as nucleophile? The answer is yes, of course. So they have lone pairs. Suppose our H2O, we have H2O present. So that is oxygen, hydrogen, hydrogen. So lone pairs are present. Okay. So lone pairs, they are rich, right? So they are rich people. They are ready to give the electron to other one. So JNV Pune, Adityan, Nikhil Shafi from JNV Palakkad. Okay. Okay. You can give me the answers in the chat box. So NH3, what about NH3? Can you tell me how many lone pairs are present for NH3? You know, chemical bonding chapter, we have studied about NH3. So how many lone pairs are present for NH3? Anyone? NH3, how many lone pairs are present? You have to tell me the answer. So NH3. So what is the number of lone pairs? Then this ROH, lone pairs are present. Then here also lone pairs are present. NH3, there is one lone pair. So they are ready to give the electron to other species. Then last one, pi electron cloud. So pi electron cloud, it is for alkenes and alkynes. So pi electrons are present. So they are also ready to give the electron to the poor guy. Okay, so that is about our nucleophile. So this is all about our nucleophile, nucleus loving. There are three types: charged, lone pairs, then pi electron cloud. Okay, electrophiles we have studied, nucleophiles we have studied. In the next year, you will study about different reactions in which nucleophiles are involved, reaction in which electrophiles are involved. Okay, so that is the thing. So nucleophilicity, what is that? It is a power of nucleophile. Okay, so electron density. If it is rich, it is ready to give. So it will search for positive center. Okay, partner. Then reactivity is high. So money, more money, reactivity high. What about stability? Stability that is very low. So nucleophilicity and stability inversely proportional. Nucleophilicity high means they are highly reactive in nature. So these are the points about nucleophiles and electrophiles. Is that clear to you? What is electrophile? What is nucleophile? So nucleus loving, electron loving, then electron deficient, electron rich. So in the chat box, you can give me some response. So that will be good. Otherwise, you are simply sitting there. I am explaining so many things, right? So you can at least give me some thumbs up. Okay, thumb is there, right? Okay, JNV Srikakulam students are present. Then good. So they will always respond. It's great. Then what about other students? Our Adityan from Palakkad, then Abhinav from Palakkad. So what about Palakkad boys? Sanjeev Sajal, Nikhil Shafi, then JNV Pune is there. Okay, I never visited this Palakkad. I heard that it's too hot in Palakkad. Okay, that is about nucleophiles. Nucleophiles. Then this is just an introduction to organic chemistry. Okay, we are just going through a bridge. We have studied physical chemistry, inorganic chemistry. Now we are just entering into the world of organic chemistry. Okay, so there are so many reactions. So nucleophiles and electrophiles we have studied. Now we can study the reactions in organic chemistry. So we want to study the mechanism. What is mechanism? How this reaction is happening? How electrons are moving? We will simply study about the name of the reaction, what is happening there. What about the mechanisms are in the next year? So time is still there, okay? So in the next chapter, hydrocarbon onwards, we will study about the reaction. Here it is just an introduction. So reactions in organic chemistry, we will study about addition reaction. Addition. Then next one, elimination. Suppose if you are doing something, teacher will eliminate you from the class. So addition reaction, then elimination reaction, then substitution reaction. You might be familiar with substitution, the word substitution. So these are the different types of reactions that we are going to learn today. Okay. So first one, addition and elimination reaction. So what is happening here in addition reaction? So first let us study about addition reaction. So can anyone tell me what is addition? Addition means what? Anyone? Addition means what? Addition means addition itself, right? So what is the definition for that? Reactions in which reagent adds to a multiple bond to give less unsaturated or completely saturated product. Okay, so just a point. Don't worry, we will explain that. Then compounds having pi bonds show this type of reaction. So what is this addition reaction? So let us take an example for that. Example. So what is the first point? Compounds having a pi bonds. So we have an alkene present here, right? So alkene, so they have pi bond, right? So this molecule is satisfying the condition. The reactions in which reagent adds to a multiple bond. So our HBr, this is called as our attacking reagent. So this is our attacking reagent. Okay. So what about this alkene? That is our substrate. That is our substrate or reactant. We can call it as reactant. No issues for that. Okay. Then what is happening here? Okay, some reaction happened. Okay. So here there is a double bond. There is a pi bond present. So read the definition. Reactions in which our reagent, attacking reagent. So India versus Pakistan. So Indian Virat Kohli is coming and it is attacking the Pakistan. So what is happening here? So pi bond that is broken in the reaction. Some bonds are broken and some new bonds are created. Here, which bond is broken? Or pi bond that is broken. So here H and Br. So I can say there are two types of bond cleavage: homolytic cleavage, heterolytic cleavage. Suppose I am saying that the cleavage takes place and this carbon is taking the electron. So I can write it as negative charge. This carbon, it has lost electron, positive charge. Then we have HBr. I'm writing it as H plus and Br minus. Then opposite charge. So this H plus, this H plus is coming and is getting attached to. So here it is, the movement of arrow is this side, this reaction. So I can write it as minus, here it is plus. Okay. So this H plus is coming to this carbon attached to this carbon. Then C plus, here we have a Br minus. So Br minus is coming and attached to this carbon. So see the product. So double bond to single bond, unsaturated to saturated. Who is attacking reagent? That is our HBr. So in the presence of HBr, there is shift in the pi electron. Then this H plus and Br minus that is coming. So we will study about the mechanism and everything later. So what is the product form? Here we have CHBr, then CH3. So what about if the movement of the pi electron is to this direction? Yes, that is also possible. Okay. So we have studied about inductive effect, resonance effect, hyperconjugation, right? So there is one more effect that is known as electromeric effect. So one more effect is there that is known as electromeric effect. So what is this electromeric effect? It is a temporary effect. It is a temporary effect. So why it is called as a temporary effect? So what about inductive, hyperconjugation, resonance? They are permanent effect. So what about electromeric? That is temporary. Why? So what is happening in electromeric effect? There is shift in the pi bond or pi electron in the presence of an attacking reagent. So in the presence of attacking reagent only, this electromeric effect will take place. So that is why it is known as temporary effect. Okay, so this is our addition reaction. HBr attacking reagent. So H plus and Br minus, it is getting attached. So new product is formed. Some bonds are broken. Carbon-carbon pi bond that is broken, and new carbon-hydrogen bond and carbon-bromine bond that is formed. Okay, so that is a one example for addition reaction. Then second example, we have C double bond O. So carbon and oxygen, who is more electronegative in nature? So can you tell me who is more electronegative in nature? Carbon or hydrogen? Who is more electronegative in nature? It's a very simple question, right? Electronegativity. So electronegativity. Here also there is some shift. There is some shift in the pi electrons. So here I can shift like this one. So negative, then plus charge. So JNV Srikakulam students, okay. Carbon, oxygen, oxygen. Then here I can write H plus and Cn minus. So Cn minus, it is coming to this carbon. H plus, it is coming to this oxygen. So what is formed here? So carbon is forming a new bond with our Cn. So you can see here carbon, new bond is formed with a Cn group. Okay. Then oxygen and hydrogen, they are forming a new bond. Then R and R dash, that is same. There is no change for R and R dash. So this is known as cyanohydrate. Okay, so this is an example for addition reaction. Attacking reagent is coming. There is some bond breakage. For example, unsaturated. Here, double bond is getting converted to single bond. Unsaturated to saturated. So what is the condition? There should be pi bond present. Okay, then homolytic cleavage we have studied. Heterolytic cleavage we have studied. Then what will be the charge present we have studied. Okay, so 2-butene to 2-bromobutene. Ketone to cyanohydrate. So this is known as addition reaction. So some new species are coming and they are getting added to our substrate or reactant. That is known as addition reaction. So don't worry about that. We will study about addition reaction, mechanism of addition reaction in further classes. In hydrocarbon onwards, we will study about different types of reaction. Is that clear? Basic idea about addition reaction, is that clear to you? Yes or no? Is that clear to you? Addition reaction, the basic idea. Some species coming, it is getting added to our substrate or reactant. So respond in the chat box. So chat box, that is for you, not for me. Okay, you can play with the chat box, no issues. You have to do it. So that is about addition reaction. Second, what is that? Elimination. So in the first case, someone is coming. Here, someone is getting eliminated. Who is getting eliminated? What is the mechanism? We have to study that. So what is the definition for that? So just read the definition. Reaction in which a two group from one or two atoms of a molecule is removed, which leads to unsaturation. Addition reaction, unsaturation to saturation. Here what is happening? Some unsaturation is formed here. Okay, definition, that is very tough, right? So we have to study about that. Example for haloalkanes and alcohol. I think I know, you know what? Haloalkanes, what is that? Alcohols, what is that? Okay, so I'm taking RX. So RX, that is our haloalkanes, right? So 2-bromobutane. So leave that. Then alKOH. What is this alKOH? That is alcoholic KOH, alcohol, right? ROH. So alcoholic KOH. So in the presence of alcoholic KOH, 2-bromobutane is undergoing some reaction. So what is that reaction happening here? So let us check the product. Then I can explain that. So here in this carbon, you can see one hydrogen. There are two hydrogen. So only focus on one hydrogen. In this carbon, one bromine is attached. Okay, then this hydrogen and bromine. We are eliminating two atoms from two carbon atoms. So 2-bromobutane, that is our molecule. We are taking two atoms, hydrogen from one carbon, bromine from another carbon. They are getting eliminated. So eliminator. So carbon should satisfy the valency, right? Tetravalent. So in order to satisfy that, a double bond, a pi bond is formed between carbon and carbon. So that is known as elimination reaction. So in the presence of alcoholic KOH, some species are getting eliminated. New species are not coming. Some are going out of the molecule. We are leaving, eliminating them. So double bond is formed here. Some other react products are also formed. We are not interested about that for the time being. Okay, so that is our elimination reaction. Then here propanol. So propanol, that is alcohol. So elimination reaction is generally shown by haloalkanes and alcohol. Next year, there are separate chapter for haloalkanes, separate chapter for alcohols. We will study this reaction in that chapter. Okay, so here we have propanol. Propanol, what is that? So we have ROH, right? ROH, we have alcohol in the presence of concentrated H2SO4. Some species are getting eliminated. So which are the species getting eliminated? So here with carbon, we have one OH present. Here with this carbon, there are two hydrogen. Take one hydrogen from that carbon. Take one OH group from this carbon. Remove that. So here water is formed. And to satisfy the valency, carbon is forming a pi bond. So CH3, CH, double bond CH2. That is our elimination. So hydrogen and oxygen, sorry, hydrogen and OH, that is eliminated. And unsaturation, double bond is formed. So this is an elimination reaction. Is that clear to you? Okay, Joan Benedict, good afternoon, you too, friend. Okay, is that clear to you? This one, elimination reaction. We are eliminating this one. Okay, so don't worry about the mechanism. We will study about the mechanism later. So we are just entering into the world of organic chemistry. So don't worry about anything. So that is elimination reaction. JNV Srikakulam students, is that clear to you? Yes or no? Then Palakkad boys, then Pune students. Is that okay for you? I can see lot of participants here. JNV Varda, JNV Warangal. Okay, I know NIT Warangal. Okay, I'm from NIT Rourkela. My friends are there in NIT Warangal. So Sanjeev, then Northeast region. Yeah, great. So we will move forward. I hope up to this it is clear to you. Addition reaction, some species are getting added. Elimination reaction, we are eliminating someone from our class. Okay, so in the presence of some attacking reagent, so substrate or reactant is present, someone is coming, some reactions happening. Reaction means some bonds are broken, new bonds are formed, we are getting a product. Mechanism later. Okay, substitution reaction. So do you know this guy? Yes or no? This is not related to chemistry. So if you know this guy, tell me the name. Who is this? Who is this guy? Anyone? Anyone? Otherwise, I will think you don't know this general knowledge and everything. It's a world champion, right? We can type the name of this guy in the chat box. He's a world champion. Anyone? Oh, JNV Nellore. Messi fans from JNV Nellore. Okay. Then others. Okay, footballer. Good. Then JNV Kolhapur. Then Adityan from Palakkad. Sanjeev. Okay, great. I think others don't know this guy, the world champion. Okay, he's a very good example. He's a motivator. He's a great motivation for everyone. He failed once. Okay, then after that, he announced the retirement. Then after some days, he changed the decision and came back. Then there are so many negative people, haters. Then finally, Ajay Kolhapur, they know the answer. So Lionel Messi, Argentinian footballer. So okay, we will leave it. Football, we will leave it. The world champion. So substitution reaction. Substitution means, so Messi, it is coming into the ground. He's coming to the ground, into the field. Okay, that time, someone should go out of the field, right? Suppose if you're a football lover, for example, Di Maria is there. Di Maria is going out. Messi is coming in. Some people will say, sir, their position are different. Don't you know that? Okay. Just substitution is happening. So that is it. So substitution reaction. What is substitution? Someone should go. someone should come. That is substitution reaction. So definition for substitution reaction. What is that? Reaction in which a group or atom is replaced by another group or atom. So Messi is replacing our Di Maria. That is substitution reaction. Then there are different types of substitution. So we have to study about that. There is free radical substitution. What is free radical? It's a reaction intermediate. There is nucleophilic substitution. What is nucleophile? That is nucleus loving, electron rich people. Then one more, that is electrophilic substitution. So that is why, so before this class itself, we have studied free radical. Then today we have studied what is nucleophile, what is electrophile. So it will attack which position. Okay, so these are the different types of substitution reaction. So in the first one, free radical is involved. Second one, nucleophile is involved. Third one, electrophile is involved. So we have to study them separately. So I repeat, next year, you will study about each and every reaction separately. There are a lot of reactions, there are a lot of examples, then those things will be asked in NEET, JEE and other exams. Okay, so first we have to study about free radical substitution. So who is showing this free radical substitution? So that is the first question for you. Okay, so it is shown by alkanes and alkenes. So what is happening here? So we have a bromine. We have a bromine. So what is this H nu? What is H nu? That is in the presence of light. In the presence of light, for Br, some homolytic cleavage. So what is the homolytic cleavage? I think you remember that point, right? Business, broken, they are getting equal amount of money. So how to represent that? We have to show fish hook arrow. So we will get a Br free radical. We will get one more Br free radical, right? Then we have CH3. Then carbon, hydrogen, hydrogen, hydrogen. Again in the presence of sunlight. So there is homolytic cleavage. Again, fish hook arrow. So I will get free radical here, free radical here. Okay. So that bond is also broken. Then this CH3, CH2 free radical and Br free radical combines. So what is formed? Instead of H, I'm writing one Br here. Okay. Then here what is remaining? We have a Br free radical. Here we have a H free radical. So what is formed? HBr that is formed here. So this is known as free radical substitution. So H free radical, it is going. Who is coming? Substitute, that is Br free radical that is coming. This is known as substitution reaction. So this is known as free radical substitution reaction. Why? Free radicals are involved here. Free radical is substituted by another free radical. So that is a point here. So you know the name of these things. One more example for you. So we have Br2. Br2, what is H nu? That is sunlight. Okay, so minimum energy. So Br2, it is getting broken. Cleavage of bond takes place. So I will get Br free radical, Br free radical and another Br free radical, right? So that is a substitute. So here we have CH2, CH, CH3. Again from here, I will take one hydrogen free radical. So here I can see HBr is formed. And in the place of this hydrogen, one Br free radical is coming and it is formed a new bond with our carbon. So free radical that is getting substituted. That is known as free radical substitution, generally in the presence of light or in the presence of peroxide. So peroxide, you know, hydrogen peroxide. There are so many organic peroxide also. So hydrocarbon, that is the next chapter. We will study about free radical substitution. So what is happening in the presence of light? Free radicals are formed. There is substitution of one free radical by another free radical. So that is our reaction shown by alkanes and alkenes. Two examples, first one alkane, second one is our alkenes. Is it clear to you? Free radical substitution reaction. Yes or no? Free radical. We will study about the mechanism in the next chapter. Okay, very next chapter, that is hydrocarbon. So free radical substitution, is that clear to you? So what is happening? Homolytic cleavage is taking place. Then substitution is there. I hope it is clear to you. Okay, if it is clear to you, we will go for the next one. Nucleophilic substitution reaction. Which are the species showing this kind of reaction? Haloalkanes. You know that, alcohols. Then there are acids also. Okay, so we have to take the example, right? So we have CH3, CH2, CH, Br, CH3. Then dilute KOH. What is that? Dilute KOH. So in the presence of diluted KOH, something is happening to our 2-bromobutane. So what is happening? So I have mentioned that it's an example for nucleophilic substitution. So some nucleophile will be coming in, some will be going out of that. Okay, from the football field like Lionel Messi. So here from KOH, I will get OH minus. So nucleophile generally represented by Nu minus. So OH minus is the incoming nucleophile. So someone should go right. So that is leaving nucleophile. So here you can check CHBr. So carbon Br bond that is broken. There is one Br minus form. Okay, you know heterolytic cleavage will take place. Br will take all the electron. It will say tata bye bye to 2-bromobutane. At the same place, no nucleophile is coming. Okay, so what is the product formed here? CH3, CH2, CH. Same. Then instead of Br, OH minus is coming. Then other product is also formed here. So this is known as nucleophilic substitution reaction. One nucleophile, it is substituting another nucleophile. So that is a point here. So if you want one more example for you, okay, you can do it. So do it yourself. So what will be the product form? So which is an incoming nucleophile, which is a outgoing or leaving nucleophile. So can you tell me? So here we have Br minus. So directly nucleophile that is given. How to identify the nucleophile? So last slide. Okay, we have studied that in today's class itself. Then here we have alcohol, ROH. So OH is present. So OH minus that is a leaving group. So OH minus that is going out. Br minus that is coming. So what is the product form? CH3, CH2, CH2. Same for both the reactant and product. Instead of OH, I'm writing Br. So substitution takes place. So what about the mechanism? So mechanism, don't worry, we will study it. Hydrocarbon chapter. Okay. So that is nucleophilic substitution reaction. So free radical substitution, nucleophilic substitution. So what is remaining? That is our electrophilic. So what is happening in electrophilic substitution reaction? So one guy is coming. That is our incoming electrophile. So one guy is going. That is our leaving group or leaving electrophile. So let us check that. Electrophilic substitution. It is mainly shown by aromatic compounds. Okay, so what is aromatic compounds? So we are going to study about aromatic compounds after some time. Okay, so aromatic compounds. Here we have a benzene. Benzene, resonance. So I can say here there is a hydrogen present. Here also hydrogen present. Here also hydrogen is present. Here hydrogen, hydrogen, hydrogen. C6H6. So one hydrogen is saying, I'm fed up with you. Okay. It is saying tata bye bye to a benzene. So this is electrophile. So general representation that is E plus. So here we have Cl2. So chlorine, chlorine. Okay. So in the presence of anhydrous AlCl3. So what is the role? This is a Lewis acid. Lewis acid. We will study about this in next chapter. What's the role of anhydrous AlCl3 in this electrophilic substitution reaction? So you have to keep it in mind. The role. ClCl, there is no H nu, there is no sunlight, there is no peroxide, there is no homolytic cleavage. So heterolytic cleavage. So heterolytic cleavage, one guy is taking all the money. So Cl plus, Cl minus is formed. Here electrophilic substitution reaction. So we need one Cl plus, that is incoming electrophile. Then this H is giving electron to carbon. It is leaving as H plus. So H plus, that is a leaving electrophile. Cl plus, that is an incoming electrophile. So what is from here? Remove H, place Cl in the position of H. Then we will get the product. So we are getting chlorobenzene. So in this case, we are getting chlorobenzene plus HCl. We have H plus, we have a Cl minus. So HCl is formed, chlorobenzene is formed. That is an example for electrophilic substitution reaction. Is that clear to you? Electrophilic substitution, then free radical substitution, nucleophilic substitution. Yes or no? Tell me in the chat box. I'm not asking about mechanism. Simple. I'm taking this one. I'm placing a new guy in that position. Is that clear to you? Simple thing. What is happening? Then what is addition reaction? So some species is coming added to the reactant. Then elimination. One is going away. Then double bond will be formed. Unsaturation will be formed. Is that clear? Yes or no? Guys, is that clear to you, students? So Janvi Varda, Janvi Pune, Janvi Srikakulam, then Sanjeev, then Palakkad, students Abhinav Adityan. Is that okay for you? Different types of reactions in organic chemistry. Just an introduction, not the complete class. Maybe you're giving some answers or things in the chat box. I'm not able to see that. Okay, I'm blind, I think. I'm not able to see any reactions from your side. Am I audible? Is that okay for you? So these are the different kinds of reactions happening in organic chemistry. Reaction intermediate. So can you tell me this one? So which are the reaction intermediates that we have studied so far? So do you remember that which are the reaction intermediate that we have studied so far? Carbocation, carbanion, free radical. These things we have studied. Carbenes and nitrines, that is higher level. There are different types of reaction intermediate. So what is happening in reaction? Okay, there is a substrate, there is a reagent, there is an attacking reagent. India versus Pakistan, war is going on. Then intermediate is formed. So before that intermediate, something called transition state is there. So what is this transition state? Let us take the nucleophilic substitution reaction. I'm taking Rx. There is Rx plus Nu minus. That is our nucleophile. Okay. So this guy will take the electrons. It will leave as X minus. But it is not happening directly. So what is actually happening? There is R, there is X. R and X, they are very good friends. Then after some years, a new friend is coming. That is known as Nu. Okay, so this Nu is trying to make a friendship with R. Okay, at the same time, X is saying, you are my best friend. So don't go with him. So slowly, this Nu is trying to make friendship with R. Then the friendship between R and X, that is slowly decreasing. So I can indicate it like a dotted lines. Okay, this is happening. So Nu is coming, then X is also there. After some time, what is happening? Nu and R, that bond is strong, friendship is strong. X is saying bye-bye to R. So this state is known as transition state. This is known as transition state. So what is the final product? That is RNU plus X minus. So intermediates, in between, there are some transition state. It is very difficult to isolate this transition state. I can't even see this transition state. Within a fraction of time, it will change to intermediate. Then intermediate to a product. So transition state, this is transition state. Some new bonds are being formed. Then some old bond between R and X, that is decreasing, strength is decreasing. Finally, R and Nu, that is making a bond. R and X, that bond is broken. So X is leaving our R. So that is happening here. So friendship or life, then husband and wife can connect like that. So transition state. So what is happening here? Energy reaction coordinate. There is a graph for you. So we have substrate plus reagent. Then it is going to transition state. Then after that, intermediate. It can be free radical, carbocation, carbanion, etc. We will study it. Then after that, again, one more transition state. Then our product is formed. So these are known as transition state. They are highly unstable. We cannot isolate this transition state. What about intermediate? So intermediate, suppose JNV Pune students are saying, sir, I want to see this intermediate. Then I will isolate that. So they are comparatively more stable. Transition state, within second, they will be vanished. Okay. So this is all about transition state and intermediate. This thing also you will study next year, chemical kinetics chapter. There is separate mechanism, how reactions are happening. Okay. So how to find? Suppose in a reaction, there is one intermediate. There is one intermediate. How to find number of transition state? Number of transition state. Okay, just an introduction. That is our intermediate, that is 1. 1 plus number of intermediate. 1 plus number of intermediate. Then you will get number of transition state. Here, how many intermediates are present? Only one intermediate. How many transition state? 2. So 1 plus 1 intermediate. So there are 2 transition state in this reaction. The very simple formula for you, number of transition state, that is equal to 1 plus number of intermediate. Okay, so I hope this is clear to you. So this is a homework question for you. This is a previous year question. Which one is a nucleophilic substitution reaction? So which are the species showing a nucleophilic substitution reaction? You have to go through the last slides. You have to go through the notes. Then someone is coming, incoming nucleophile is there. So outgoing nucleophile is there. So which is that reaction? So what is formed? Whether unsaturation is formed, whether single bond is formed. You have to check that. So we have studied some of the reaction. This is RMGX. We will study about Grignard reagent in the next class. Grignard reagent. Okay, in the further classes, we will study about that. So from the things that we have studied, you can answer this question. Okay, so this is a homework question for you. You have to do it. You have to go through the points and find the correct answer. So time, it is almost up. It is 3:45. So we have to end it here. So today we have studied about electrophiles, nucleophiles, very, very important. Then different reactions happening, addition reaction, elimination reaction, then nucleophilic substitution, electrophilic substitution, then free radical substitution. Last, we have studied about a graph, reaction, energy, then intermediate, how many intermediates, how many transition states are possible. So our transition state, it is not possible to isolate. Our intermediate, it's somewhat stable. Then Rx and Nu, that is example for transition state. We will study about all these things in detail in the further chapters in hydrocarbon and also in the chapters in your 12th class. Okay, so you can do the homework question. We will see you in the next class. Then bye-bye. We will see you in the next class. So we will study about aromaticity. What is aromaticity? So question was asked in NEET 2022. So we have just mentioned aromaticity. So bye-bye, students. So we will meet in the next class. I'm ending it here. Bye, JNV Kolhapur students. Then Adityan, Abhinav, JNV Gondia, JNV Daman, JNV Nellore from Andhra Pradesh, right? JNV Pune, Warangal. Okay, NIT Warangal. I know NIT Warangal. Okay, then bye-bye, students. We will see you in the next class. So I'm ending it here. So do the homework question. Okay, JNV Daman students. So first one to join the class, then bye-bye.